Okay, good afternoon, everybody. My name is Tom Scase. I work for a company called Avecto, and I'm one of the senior technology consultants there. And today what I'm going to talk about is how, if we can remove privileges, we can actually remove the threats. For anybody that's kind enough to actually leave their feedback, the session code is number 34. So any questions as we're going through the session, please feel free. I kind of like to keep these interactive. Let's go through a few slides, set the scene, and then I'm actually going to spend most of the time actually going through a live demonstration of the Defendpoint technology. And Defendpoint is privilege management and delegation, privilege elevation and delegation management technology. As I said, we're going to go through a little demonstration, so please feel free to ask questions as and when you think of them. So, kind of think of Nirvana, think of what a CISO would love to see. So, yeah, this is where we want to get to. Where is the end goal? So, think of it where all of our endpoints are secure. None of our users are logging onto our desktops of local administrators. We're able to meet compliance mandates that are asking for us to achieve least privilege. Users are able to do their jobs without being restricted. They're very productive. They're happy because they're not too locked down. And management costs are now reduced because it's actually simple to manage these end users and their devices. So if that's the ideal, how do we actually achieve this? Well, let's have a look at what the industry experts are recommending. They're saying, number one, the best way to improve the security posture of your environment is to introduce application whitelisting. Because if we introduce application whitelists, it means we're only allowing trusted applications to run, and then anything that is unknown is then blocked. Application patching is important. The same as operating system patching is also important, because there we want to patch the vulnerabilities to make sure our environment is as secure as we'd like it to be. And number four there, let's reduce the administrative users. Let's reduce the number of admins that we've got logging on into our environment. So if this is the advice that the industry experts are recommending, why is everybody not actually following this advice? And the answer to that is because it's typically been seen historically to be difficult to actually achieve. And as I said there, that has historically been difficult to achieve. And also, one of the things that this doesn't really take into consideration is our end user's experience. So how do we take a different approach with Defendpoint? How can we actually achieve that fine balance between security and end user flexibility and end user freedom? Well, we can do that with the Defendpoint technology. Number one, we can take away the admin rights from the end users. So rather than giving the user the admin rights themselves, we're effectively applying the privileges to the applications, the tasks, the scripts that actually need those privileges. We can achieve simple whitelisting. We're blocking the unknown. We're providing lists of trusted applications, but as you'll see from the demonstration, typically whitelisting or traditionally whitelisting has always been seen to be a little too rigid, blocking the unknown and only allowing the trusted. But what about that grey listed area? We've got users in our environments that need to introduce and maybe run and install applications that may never have been seen before. So how can we implement this type of security solution but still meet the requirements from our end users? There are applications that we do trust that have vulnerabilities in them. Maybe we can't patch as quickly as we'd like to. So how can we protect those applications that are targeted in the content type-based attacks? We can do that with our enhanced security, our trusted application protection, and finally, one of the things that it's important to do is to understand exactly what's going on in our application landscape. And we can do that with actionable intelligence with our enterprise reporting capabilities. So what I'm going to do now is going to jump into a bit of a demonstration. So here what we're going to do is we're going to bring up one of my machines that's just got running on this desktop. And first thing I'm going to do is run through some of the challenges associated with taking away admin privileges, because we've highlighted that in one of those 4 security recommendations is to remove admin rights, and the actual task of removing admin privileges is quite simple to achieve. We have people that are users that are in the local administrators group. Well, let's just take everybody out of the local admins group, and then they're now logging onto that desktop as a standard user. That's the easy step. The problem is what it leaves behind. It's that limited standard user account, which is too limited for certain users within our organization. So this demo environment that I've got set up here, this is a Windows 10 Creators Edition desktop. Our software supports any of the Windows OSs all the way back down to Windows XP SP3, and also in the server environment as well, Server 2003 SP2. Up to the latest revisions of both the server and desktop OS, so Windows 10 Creators Edition and Windows Server 2016. This user that's logged onto the desktop used to be an administrator. They used to be an administrator because they required this flexible end-user experience. Think of them as being maybe an engineer, think of them as being a developer, maybe one of the C-level executives. In the past, they've demanded that they needed admin rights to be able to do their job. But we've highlighted the challenges or the security problems with having users being local administrators. If we've been listening to the sessions earlier, from Sammy, etc., highlighting the fact that having users logging onto the desktops with local administrators causes a number of security issues. The main ones being the fact that if I'm logging onto that desktop as a local administrator and a piece of malware runs in that same context, then that piece of malware has access to the full system, the keys to the kingdom, and a lot more damage can be caused than if that user was a standard user. So what we've done on this user, we've now taken away their privileges. But let's have a look at some of the limitations to that user's experience now. So I was an administrator before, and now when I come to run my applications, which I need to do my job, we now see this user account control message. And this is the Windows operating system identifying that that application needs elevated privileges, maybe because that application is trying to write to somewhere in the file system or the registry that that standard user now doesn't have the privileges to write to. And this is just the user trying to execute an application that's already installed on that desktop. The same for other applications, other third-party apps, but it's not just applications that are installed on the desktop or third-party applications. There's hundreds of applications or applets, control panel applets that also need elevated privileges for those changes to be made. So imagine I'm a laptop user and I'm sick of every time that I accidentally hit the power button, it shuts my machine down. I want to make that change just to improve my end-user experience on my desktop. And I'm getting this same Microsoft UAC message prompting me for this password, an admin password, which I now don't have. So at the moment, I've got quite a poor end-user experience. If I did want to have this setting changed or run that application, would I ring the support desk, ask them to remotely connect to my machine and put the password in? That may work once or twice, but I'm obviously going to get very annoyed. There's going to be a large volume of help desk support calls each time the user wants to make these small changes. And essentially what's going to happen is, because that end user's experience is now at a point where I can't do my job, I'm going to demand my admin rights back. And then we're back to square one. But even if we did take away the admin rights from this user completely, that desktop isn't as secure as we'd like it to be. This user has access to the internet. They've browsed the internet, they've downloaded a number of applications, they maybe have brought things in via USB sticks or maybe sent some executables over the internet, over email, for instance. And my user, we've just seen there, a standard user, I can still run applications which may have been downloaded from unofficial websites. This executable doesn't need any installation, it doesn't need any admin rights to run. But what's to say that there's not something malicious attached to that application because it wasn't downloaded from an official website? There are also applications which we're all aware of that don't necessarily need to be, that can actually be installed into the user's profile area, so these portable applications. I'm sure we don't want torrent applications running on the corporately built desktops. If my user goes to install this application, because this app actually does require an installation, here it actually asks me where do I want to install it. The default location is program files. I would have been able to install into program files if I was an administrator previously, but now we've taken away that user's admin rights, and there's now inbuilt security for that standard user, which prevents my user from being able to modify and change certain folders within the operating system. And one of those being program files x86, and the other folder is the Windows folder. So if my user does try to install that application into program files, this is some of the limitations of the standard user profile, which is actually good. We don't want the user to be able to install into that location. But as I mentioned, this, just like many other applications such as Chrome, other browsers, Dropbox, they can actually be installed into the user's profile area instead. So this application, it's not been installed into program files, but it's been installed into the user's profile, and this user now can run this torrent application on that corporately owned desktop without being an administrator. So obviously these types of applications are a great way for the user to introduce malware, to introduce unlicensed software, and we want to be able to control what the user can and can't introduce and run and install on that desktop. But as I've just highlighted there, this isn't an admin rights problem. This is very much just a standard user problem. And also, maybe we want to encourage the user to be able to try and find better ways, more innovative ways of working. And maybe the applications that are provided as part of the operating system, part of that desktop build, maybe I'm not quite happy with those applications, and maybe I want to introduce my own apps. And for instance, if I'm a developer, an engineer, maybe I want to debug some log files, and I'd much rather use an application like Notepad++, because it's better for me. I find it's a productivity application. There's no problem with licensing. My user wants to download and install this application, but similar to those other privileged tasks that I wanted to perform before, I'm limited. I can't run or install that application. And my IT teams might be quite happy for me to install that application. So far, if we think of my end user experience, I've had a poor end user experience. The IT teams are going to have a large volume of support calls. So what we need to do is we need to provide that user with the capability to have that flexible working experience, but still maintain the security of that desktop at a suitable level that the IT department wants to manage. One other thing we need to start thinking about is we see more and more nowadays with the ransomware style attacks. We have content on the desktop. So my user has access to this content. The standard user has the ability to write to content, and this is where ransomware becomes so destructive in the fact that it's not an admin rights problem. In a similar way that you saw the user being able to introduce applications and install stuff into their profile, I can actually write content as a standard user, and I can delete content. And pieces of malware that run in the context of that standard user will also have the capability to write to those. In this example, in my demo, my user may just have received a phishing email, some form of social engineering, whether that be a link to a website or maybe a piece of content that's got some malicious code in there. But all it takes, it doesn't matter how good your educational programs are, it takes one curious user to click on the link because this looks like it's come from my bank, it looks like it's come from a colleague in the organization. My user just clicks on that link, it takes them to a fake website, and instead of rather than going to my user's actual banking website, it's gone to a fake website. There is a vulnerability in this version of the web browser, or vulnerability in Java in this case. There's a drive-by download which has taken place, and because that piece of ransomware runs in the context of the standard user, and a standard user has read and write access to content, very nice of this piece of ransomware to give us some visual feedback, because most of the time we find that ransomware, the only time that you find out that you've been hit is when it's too late. And you can see now that the content on my desktop that was accessible is now been encrypted. And the only link that's accessible is this link to a website which tells me how I can pay the ransom to get my documents recovered. So these are the types of challenges. We want to be able to allow our end users to open up email attachments safely, to be able to browse the internet without the fear of these types of attacks. But we do have vulnerabilities in applications. Two of the four recommended strategies for improving the security was to patch your OS, to patch your applications, but how quickly can we roll out those patches? There's going to be vulnerabilities in apps, maybe vulnerabilities that we're aware of, maybe the 0 days that we're not aware of. So how are we going to allow our end users to run these high-risk applications without the fear of these types of attacks? So what I'm going to do now is Defendpoint was disabled, so the Avecto technology was currently disabled on that machine. I'm just going to recover my documents. So I've got my documents back. A lot simpler than it is, I'm sure, to recover documents in the enterprise from a ransomware attack. But now I've got my documents back, and what I'm going to do is I'm going to enable Defendpoint, which has currently been disabled on that machine. I'm then going to walk through those same use cases and show you how Defendpoint can alleviate a lot of those problems. Okay, so what we've done now, I've enabled Defendpoint. And in particular, first of all, I've enabled the privilege management capability of the software. So I mentioned before, privilege management is all about assigning the privileges to the applications, the tasks, the scripts, instead of giving the admin rights to the actual user themselves. So remember before when my user clicked on their engineering application, this UAC-enabled app, they saw the UAC message box, that Microsoft User Account Control message box, because the Windows operating system identified that the application itself needed elevated privileges, and it prompted with the Microsoft UAC. Now when the user runs the application just fires up seamlessly. If I go to the power options, I went to this link here. You see another UAC-enabled link that would normally prompt with UAC. When the user clicks on that shortcut, the user has the ability to make the changes to that setting as they would have done when they were an administrator. But I'm just logged onto this desktop as a standard user. Now, one of the things that we've done there is we've provided the end user with a seamless experience. We've launched that application. We've elevated the privileges of that application. We elevated the privileges of the control panel applets. We can elevate the privileges of scripts, etc. One of the things that you didn't see there was any messaging, any end user feedback. And that's because it's one of the end user experiences we can provide with Defendpoint. But one of the main strengths of the product is our fully comprehensive messaging, which can provide education, warnings, and instructions to our end users. To give you an example of those, if I go to my applications, this backup and restore app, another application that needs elevated privileges. When the user runs that application, you see a small toaster notification that pops up in the bottom corner just to let the user know that the IT teams have elevated that application on their behalf. If I go to one of my other apps, so the developer application, here when my user launches this app, we start to see some of the fully customizable messaging. And because we're at a PDS event, I thought I'd put the PDS branding for this message box. But here you can actually customize the messaging, the branding, the text. Basically what this is doing is providing the user with a very simple gated access to the application. This application requires elevated privileges, and we're just simply asking the user, are you sure you want to continue? Do you want to run this app with those privileges that it requests? One of the things that we can also do with the messaging is we can support multiple languages. So we actually support all of the languages that the Windows operating system supports. So if the user has configured their Windows operating system for the Dutch language, when the user launches an application and we present a message box, it can actually be matched to the correct language of that operating system. So here, for the user to gain access to the application with the privileges that it requires, they simply press yes, and this application is now running with those elevated privileges that that application needs. Now, one of the questions that typically comes up at this point is, great, that's brilliant, Tom, but how do we know what these applications are? We can't go and take all of our admin privileges away from our engineers, from our developers, from our C-level executives. without understanding what all those applications are, because we don't want to leave them with an application that now doesn't run, which means that they can't do their job. The great thing with Defendpoint is that we actually have what we call a quick start policy. And within our quick start policy, it actually leverages features within the product, which means you don't need to know what those applications are before we take away the user's privileges. The features in particular that we're leveraging, one of them is actually called the user account control interception capability. So when I started the demonstration, one of the things that was common across those applications that needed elevated privileges, they all kicked up or prompted with the user account control message. What we do with Defendpoint is we use that trigger as an indicator that that application needs elevated rights. So if the Microsoft operating system sees that that application needs elevation, it would have prompted with the user account control message. We intercept that request, and we can suppress the message box, and we can act on that application. So we can elevate the application only if it needs elevation. The benefit of that is that we don't need to know what those applications are. We've got inbuilt policies, pre-configured policies that come out of the box, where you can actually just deploy Defendpoint across your organization, take away the admin rights from your end users, and Defendpoint can apply an admin-like experience to your users, or one of many different levels of flexibility that you'd like to deliver to your users. One of the other things that this actually leverages is all the different types of messaging that we can provide. The ones that you've seen so far are very basic messages, but we can also provide different messages which allow the user to interact with the message box to authenticate themselves or to gain access to an application through some interaction with the help desk, for instance. So what we've shown so far is that we can absolutely take away the admin privileges from even the most demanding of our end users, because Defendpoint is going to elevate the applications, the tasks, the scripts that need those privileges, so we take them away from the user and apply them to the applications as and when they need to. Another thing that we can now take advantage of is the fact that we've stripped away the admin rights from the end user. There's inbuilt protection on the operating system, which we can now leverage. And we can now look at meeting one of those other recommendations, which is applying a whitelist. When we've talked to customers in the past about whitelisting, we ask them have they tried whitelisting projects before. They typically say they've tried and they failed. The reasons why they failed previously is traditionally, when people have tried to implement whitelisting meant actually identifying every application that was on your base build desktop, assigning hash values to those executables, and then managing a list of thousands of hash values as your whitelist. Now, that worked momentarily, because as soon as we updated any of our applications, as soon as we updated the operating system, those executables have now been updated and now changed. The hash values now don't match, and that whitelist is now outdated. So maintaining that whitelist is very difficult. It's difficult to maintain, to keep up to date, and also those whitelists are very, very rigid. It's either a yes, you're allowed, or blocked, no, you're not allowed. And when we say that we've got people in the organization like developers could be creating code. Our engineers may be visiting a customer site where they've been presented with a piece of software which they need to install on the desktop, so a piece of hardware can communicate with their laptop. These are pieces of software that are unknown, so how do we provide that level of flexibility while still providing the security of a whitelist? And again, this is where Defendpoint can help. So if we take a look at and I'm going to use this as a bit of an example here. If we talk, one of the things that was mentioned earlier, and I think Sammy touched on it as well, is that the limitations of that standard user account, there are areas of the operating system which are now protected. So as before, if I was an administrator, I could install applications into program files x86, and I could update the operating system, and all the Windows executables would go into the Windows folder. But now I'm a standard user. I don't have the privileges to modify, oops, let me just turn that off. All the benefits of a live demo, guys. So if my user now tries to modify modify something within the program files, we see that the program files directory is actually protected with NTFS permissions. The same thing if the user actually wanted to go and install something into or make changes within the Windows folder, for instance. So this user is limited because they're now logging on as a standard user. And what we can do with Defendpoint is we can now leverage those 3 protected folders to create a very simple whitelist. So if I actually go and check out my Defendpoint whitelist, rather than this being actually thousands of hash values that I mentioned before of executables, we can now leverage the fact that we've got these 3 protected folders that a user doesn't have the permissions to write to. Sammy did actually touch on some earlier about the ones that are writable in the program files, the Windows folder, but just for this demonstration, we're going to talk about this and we can see how easy it is to actually manage these whitelists. So if we've now got 3 folders as our whitelist, this becomes so much easier to manage. Because now if we think of a vulnerability that's identified in Adobe Reader, for instance, we need to update Adobe Reader across the board. Well, what we do is we install the update using SCCM or whichever. It pushes the application, the new files into program files, and there we go. We don't have to update this whitelist. If we do the Windows updates, all the files will now be updated into the Windows folder. We don't have to make a change to this whitelist. So this whitelisting now becomes achievable, and it's very simple. We don't have to keep constantly updating it because we've got this baseline that we're going to use for our whitelist, but we can still leverage the actual the benefits of the whitelist. So if this was just the foundation layer for my whitelist, what does this mean now to any applications that fall outside of the whitelist? Well, in the same way, if I just, let's go back to that. So this is the whitelist. This is the list of trusted applications based on the folders. Let's go to my user's downloads area. What happens now when my user tries to run one of these applications? This executable that didn't need any admin rights to run, it didn't need any installation. The user goes to run the application, and now this is actually handled by our exception handling capability. So here what you can see is, yes, we blocked it. It's the default deny. It's the most secure way of protecting your environment because it falls outside of the whitelist. But there could be a genuine business reason why this user wants to install this application. So we can provide them with functionality to request access. So I've got reason. With Defendpoint, we can actually do scriptable actions. So this submit a ticket direct from the message box could actually interact with a ticketing system. We could raise a ticket on behalf of the user because we can create scriptable actions that can interact with any ticketing system that has an open API, such as ServiceNow, Remedy, and we can raise a ticket on behalf of the user directly from our messaging. Just for this demo, what I'm going to show you here, the user can click submit, and we can also integrate into the user's email client, pre-populate it with some information about the app, populate that with the support desk email account, and the user can just click send. But there may also be applications which we know are bad. We don't want we're seeing users that keep requesting every now and again. So we can provide very much a blacklisted type message. No, you shouldn't be running this application. This goes against corporate policy. Please click on this hyperlink to review the fair usage policy. So we can educate with the messaging. And then we've got this downloaded application, Notepad++, which, as we said, maybe we're quite happy for users to try and introduce these applications, but maybe we're not the very latest version because it's not been tried and tested on that build. But what we can actually do is we can provide the user with a link. In this case, if we have a read of that, if anybody that can't see that, it says, hey, why don't you try to see if this application is available in the App Store? And what we've done with Defendpoint, we've just created a hyperlink here. It takes my user to a read-only network share that just has a number of these little MSIs or executables. The user can't actually write anything in here. So access is denied because it's a read-only network share, but there's an older tried and tested version of Notepad++, which there's no problem with licensing, no problem with any conflicts on the desktop. And what we can do there is we can provide that user with the capability to run and install this application from this admin-approved admin-approved location. So we're giving some of that flexibility back to our users. It's not so rigid with that whitelist. The way that we handle applications that fall outside of the whitelist, with our exception handling capabilities, we talk about grey listing. But there are applications that the IT teams know about. What about applications? I mentioned before, think of a developer, an engineer that's on a customer site, laptop user, not going to be back in the office anytime soon. And I think we can all relate to the fact that actually I've just gone home, I need to print some important documents the following day, and my printer has blown up. I need to go and buy a brand new printer. I bring it back, plug it in via the USB, and it's asking me for the printer driver to be installed. I've got the printer driver is on a CD, and I try and run that printer driver, and what do we see? Well, the whitelisting is now blocking that application because this is a brand new executable, never been seen before, and it's blocked. So that's great, thumbs up from a security perspective, but maybe we do need to allow our C-level executive to install this because they've got an important meeting the following day. The way we can actually achieve that is using, again, our exception handling capabilities. We've actually got this on-demand functionality. So here I've just done a right-click. We can integrate with the run as admin, and we can actually intercept that in the very same way that we can intercept the UAC message. Or we can change that and provide this customizable text area, which says, in this case, run as administrator, in brackets Defendpoint. But obviously you could say run as admin and put the company name, for instance. But the important thing to take away here is what this now presents the user is with the challenge and response message box. And think of this user as being completely disconnected from the network. I'm not connected to the network, I'm not connected to the internet, there's no way of us pushing down a change to the policy to allow the user to run that application. But that doesn't matter because we've generated this unique code, and that's done using an algorithm. There's a shared key which has been pushed down to this endpoint, so it's known by the endpoint, and that is exactly how we can do this completely offline. It takes properties of the situation, so the name of the exe, the hash of the exe, the username, the device name, the time of day, etc., and creates this unique code. The user can then ring the support desk. The support desk pick up the phone. They've also got access to the shared key. And what they can do is they can now listen to the case. And if I was the engineer on site, needed to install a piece of software, then, okay, we appreciate that's your role. We're going to give you this capability to install that application simply by taking a copy or listening over the phone to what the code is. They put it into the response code generator, and then a unique code is generated for that application and that situation only. The user can then click authorize all through the messaging, and now they have that capability to break the glass in that situation and install a piece of application which is, an application which has never been seen before. So what I'm demonstrating there is that the break the glass functionality. It's not something that has to be provided to everybody, but think of those very demanding end users. We can actually apply a policy, push out a whitelist, push out identified applications which need elevation, but anything that's missed, you don't have to worry about what's been missed because we have the exception handling capabilities with the challenge and response and with the fully customizable messaging, which can provide that user with the flexibility that they need to be able to run those apps, those tasks, those scripts. Something which always sometimes comes up now as well is that they say, well, that's great, but we have our help desk, our telephone support is closed during certain hours. So how do we provide the functionality to the people that are out on site, maybe in the middle of nowhere, and we actually want to be able to them to self-authenticate? Well, with the products, we can actually create what we call Workstyles, and Workstyles are kind of rule sets that can be applied to different users, different user groups, machines, or even time-specific filters. And I've got a filter here, a Workstyle, which is only going to apply during certain times of the day. So this is my out-of-hours Workstyle, so they'll get a different end-user experience when the help desk is closed. And I'm using a UK time at the moment, so we're at an hour behind, but at 12:35, I'm just going to enable this now. So now this Workstyle is now active. The Workstyle wasn't active before, but imagine this is now out of hours, and the user wants to do that request again. This time, rather than seeing the challenge and response message, We're actually just going to give that user the capability to self-authenticate as long as they provide a reason and put in their Active Directory password. So this is just an example there of the different types of gated access, the different levels of flexibility that we can provide with the product to make it as secure, as lenient as you'd like, because as much as security is on the number one on the agenda, we can't take away the user's capability to be able to do their job. So we can meet any of these different types of flexibility requirement. So coming close to my time, I've got about 10 minutes left. This is very good for me. I'm usually well over schedule. One of the other things that we looked at was how do we protect from the types of ransomware attacks, these pieces of malware that run and cause the damage in the context of a standard user. So we've managed to take away admin rights, but we've seen there that actually if we can implement whitelists, what happens to those binary-based attacks that include a binary drop into disk, an unknown binary? Well, we've got a whitelist in place now. We've got a whitelist which is only going to allow trusted applications, known apps to run. And if the user didn't initiate an application to run or execute, then maybe their pop-up comes up, asking them for authorization, asking them to get a challenge and response number. But if I didn't initiate it, then I know it's not something that I tried to run, and we can block malware in that, using that method. But what about the malware that's more advanced, that maybe leverages some of the trusted applications, some of the whitelisted applications in the attack? Sammy mentioned again before, I keep referencing Sammy's session, but it highlights a lot of things that we talk about day in, day out. We're talking about these users that are, need quite a lot of flexibility, whether there be engineers, developers, even the support desk staff. My use, I remembered it, PowerShell. I knew it was Power something. The PowerShell is a very powerful tool. The cyber criminals have got wise to the fact that they don't need to build a binary to actually drop it to disk, which could be blocked by a whitelist. There's an application that's very capable that's already installed in the operating system. So maybe we want to limit who can run this application or not. We can do that with whitelisting. We can blacklist that application also for people that don't need to run the app. But what about our users that do need to run it? What if an application such as PowerShell or the command prompt is used in part of the attack? And what we've got within Defendpoint is what we call trusted application protection. And what that's doing, it's looking at trying to add an extra layer of protection to these vulnerable applications, these high-risk applications which are typically targeted in a content-based attack. Applications that are classed as highly vulnerable are applications like your web browsers, like your Office applications, like your Adobe readers. These are applications where we can add additional protection in place to protect the end user and the endpoint from attacks which may leverage those applications in an attack. As an example, if I just go to, I'm going to enable the trusted application protection work style. I'm going to go back to my phishing email that came to me as looked like it's come from my bank. The actual way this attack works, when the user clicks on the link, it goes to a website. The website actually exploits a vulnerability in Java. Obviously, that web browser is still the same. That vulnerability is still there. I've got 5 minutes left, which is a great little warning. So what actually happens now is, even though the vulnerabilities, etc., are there, what you'll see, and you saw that the user themselves could launch command prompts, could launch PowerShell. When the user clicks on this link, the same attack happens, but what you'll see in the bottom right now, a little notification has popped up, and anybody that can't read that, it actually says the command prompt has actually been blocked. So it says it's been blocked because it was launched via Java. So what we've done there is we've actually got not just been able to implement whitelist, but we can actually put contextual awareness in place of which applications are being launched as child processes from these vulnerable high-risk applications, such as your web browsers, your Word documents, and Adobe Reader, etc. So what we're doing there is we're just making sure we're checking who the parent process is, and we can actually make decisions on which application should or shouldn't run. So adding further protection to the desktop. Finally, one thing that I mentioned at the beginning of the session, another thing that we want to be able to do is gain visibility, understand better exactly what's going on with the environment. So with Defendpoint, one of the things that we can do, or a number of the things that we can do, we can block apps, we can allow applications, we can elevate the privileges of apps, and we can also give users the capability to request access to applications that fall outside of that whitelist or authorized lists. It's very important for us to understand exactly what's going on there, and we can do that within Defendpoint Insights, which is our enterprise reporting tool. Here you can see the summary page. We can see what's happened over the last 12 months, the last month, the last 7 days, or the last 24 hours. If I just do a refresh, we've been doing things during this session, so it says 16 and 0. If I do a bit of a refresh, we should see some more applications that have been discovered. So here, the net new applications, 21 discovered over the last 7 days. 67% of those, so just over 2/3, actually needed admin rights. A third of them didn't. There's been a single user request. We've identified here that people are still logging on with admin accounts. Why is that when this project is all about removing admin rights? We can actually track to see who's still logging on with admin rights. We can see people that have tried to tamper with the technology. So we have one of the most comprehensive anti-tamper technologies in the market, and we can track when people are trying to tamper with it. And here you can actually start to see the UAC matches. So I talked about that quick start policy that will automatically elevate applications that need elevation based on user account control interception. We can see a list of what those are in here. And we can also, I'm going to show you one that we can actually track from the on-demand, so the user did a right-click and elevated an application. Here you can just see another app that my engineer tried to run a Hilti installer. If I move across, show you the detail of the information that we can get from the application. We've got a description, we've got the user, we've got the host, and I click on this one, and hopefully it'll become a little bit larger so you can actually see. Here's all the metadata about the application. And this is the installer, the start of an installer. It's the exe, we've got the publisher, we've got the hash. We've actually got where the application was downloaded from, so we can track where the origin of an executable. And that's obviously good if it's maybe a piece of malware or maybe creating some form of, or some policies which maybe you want to allow users to download stuff from a certain website. What's also good is if we move down here, you can actually see the process hierarchy. So there's the executable, but that spawned a setup. I click setup, and we get all that same very useful information about the setup executable. We've got version numbers, we've got the command line. Scrolling down further, we can see all of the processes that the application spawned as well, and we can use this to create more secure policies and improve the end user experience. Very quickly, another thing that our customers love about the product is how simple it is to configure and manage moving forward. So what we can do is, if anyone's ever configured a firewall, they'll be very familiar with the way that we configure the product with Defendpoint. We have rules that match or go against application groups, and we basically have the rules that are evaluated from a top down. So we've got blacklist at top. Things that we know are bad, we can block them, and we can provide a different end user message to the ones that are in the capture all that fall outside of the whitelist. We can elevate applications as we're moving down this list. You can see here how we've got the any. So we don't need to know what applications are. These are the kind of star.exe, star.mmc. We can elevate and manage applications that fall through an exception list that we don't necessarily know what they are. And at the very bottom, we've got the whitelist, and we've got the capture all section. So this is very simple to manage, the logical flow of application evaluation. And one of the other things that we can do is, you saw there that we were identifying applications that we have been brought in, identified during the discovery process. But what we can do is we can insert applications and pull them through from that enterprise reporting. So applications that we discover, maybe applications that may have never been seen before, that printer drive or the engineering application. Maybe someone actually went through the request privileges, the challenge and response to get access to that application. That will be raise an event into our enterprise reporting, and we can actually bring that into the policy. You can see all the different application types that we support. There's over 14 different application types. executables, PowerShell scripts, remote PowerShell scripts, so we can actually assist in our service desk guys remotely managing servers, for instance. But the one that probably our customers use the most is the events, because we can actually bring in events that we've found from, that we've discovered from our machines whilst the product has been in the quick start policy. Here you can see, let's specify applications that have triggered UAC, 27 of them. Click next. We can target certain times of the day. See if we've got one for today. There's 10 of them. Click on this link. There we go. We've got the Hilti application, the stuff that I was running on my desktop, the printer itself, and I can simply just add these to the list. So not just simple management during the start with the quick start policy, but the way that we can actually improve the end user experience and improve the security of the environment, it is also simple moving forward. So finally, you can see all the different slides that I had available. I'm not much for going through the slides, but I think I'm just about finished on the time. So thank you everybody for joining this session. If you do have any feedback, the session code is number 34. But happy to take any questions. We're just over on the right-hand side at the Avecto booth. Thank you.